Hello everyone, good evening to one and all. Myself Srinivasrao, faculty at MedEG platform. आज का सेशन है गेट थ्रू क्वेश्चंस in the area of discrete mathematics. So I am planning to take 2 hour session. So today I am going to discuss very interesting questions, and I have secured all India rank 69 in mathematical analysis paper in the year 2005. I hope my experience will added extra advantages for your preparation. So with that hope, I came up with a good number of questions. Okay, let me start first question, friends. Let me see how many of you joined in the live session first. Yeah, Mukul Gupta, Kundan Kumar, good evening. So we want to utilize this time properly. That's the reason I am moving to the first question without wasting your valuable time, friends. Okay, let me start first question. So in this question, the set S contain 12 elements. The set S contain 12 elements. That set is to be partitioned into 3 sets named as A, B, C. And all these 3 sets are having equal size. All these 3 sets are having equal size. And it also satisfies some extra condition that A union B union C is equals to given set S, and intersection of any 2 sets must be equal to pi. So in order to fulfill these conditions, the number of ways of partition of S. So how many ways we can partition the set S to fulfill those conditions? So for every question you take maximum 1.5 minute time, friends. Okay, so please try this question. Good evening to one and all. Thank you, Mohan Kumari. Thirty seconds already completed, friends. There is a set S which is partitioned into 3 sets named as A, B, C, and it further satisfying 2 conditions. A union B union C is equals to total given set S, and intersection of any 2 must be equal to pi. How many ways we can partition given set S to meet that condition? Yes, the time limited for this question is already over. So whenever we try to answer any question in discrete mathematics, the first thing is you have to identify the concept in the question, friends. Okay, so if you observe here, they are partitioned the set into 3 sets A, B, C. The strategy is very simple here. The strategy is they are dividing 12 objects into 3 groups. Now immediately you have to recall the concept of division and distribution principle in the permutation and combination concept. Alright, so there are 12 objects which are dividing them into 3 groups, name them as A, B, C, where each group must have 4 objects. So why they are having 4 objects means they clearly mention that A, B, C are of 3 equal size. Alright, friends. Okay, the solution is very simple and the concept is very simple here. Look at here, we are having set which contains 12 elements. So S consisting of 12 elements, friends, starting with 1, and so on ending with 12. So we are dividing set S into 3 groups, name them as A, B, C, and they don't have any intersection part, right? So what is the basic principle in this question means? The principle is a division distribution principle, friends. Okay. For example, if we have n objects in our hand, and if you want to divide n objects into k number of groups, if you want to divide n objects into k number of groups, okay, name them like n1 group and n2 group and so on nk group. There are n distinct objects are there. You are dividing them into k number of groups where size of each group must be same. It means that cardinality of n1 is equals to cardinality of n2 is equals to and so on cardinality of nk. So this problem belongs to division distribution principle where size of the groups are fixed and they are equal. Then how many ways we can divide that group, right? So apply the shortcut formula, total number of objects factorial by, that is n factorial by, total number of objects factorial, that is n factorial by, size of the first group factorial into size of the second group factorial into and so on size of the kth group factorial. But whenever group size are equal, you have to divide the total value with the number of equal groups, that is k number of groups are there here, right? Okay, you can take k factorial. This is the basic funda and this is the basic principle. So we already discussed this concept in the class, right friends? Okay, what is k indicates here? K indicates that number of groups, there are k groups are there and k groups are having equal size. Clear? So with this part division is completed, right? Now you are distributing them into k number of objects, right? So if you want to distribute them into k number of groups, how many ways we can distribute them in means that is k factorial ways. So apply same principle here also. Total we are having 12 objects, total number of objects factorial by size of the first group factorial, that is 4 factorial, size of the second group factorial, that is 4 factorial, and size of the third group factorial, that is 4 factorial. Since we are having 3 groups of equal size, therefore we have to multiply them with 3 factorial. Just imagine you are having 12 objects, you are packing them into 3 packets where size of each packet contains 4 elements. Now gift packets are ready. Now these gift packets must be distributed among 3 persons or 3 sets like A, B, C. How many ways we can distribute these 3 gift packets among 3 persons or 3 sets A, B, C? That is 3 factorial ways. So therefore it should be multiplied by 3 factorial ways. This is called division principle and that is called distribution principle. Okay, the basic strategy is very simple. You are having 12 objects in your hand, you are packing them into 4 objects. Now packets are ready. How many ways we can pack them means that is 12 factorial by 4 factorial into 4 factorial into 4 factorial into 3 factorial. After having 3 packets, now you want to distribute these 3 packets among 3 sets A, B, C. How many ways we can distribute them? That is 3 factorial ways. Now 3 factorial get cancelled. The denominator we are having 4 factorial whole cube. Hence answer is 12 factorial by 4 factorial whole cube. So the correct answer for this question, that is option B is correct answer. Most of your answer is option C. Option C is not correct because distribution is also required. Okay, option B is correct answer. Please copy the answer. Please check it once. Most of you gave answer is option C, but option C is not correct. Option B is correct, friends. आज का सेशन बहुत इंटरेस्टिंग है. If you have any doubts, please ask in the comment box, friends. Okay. Alright, next question. Look at the next question, friends. Consider the following graph, where graph contains exactly 11 vertices. Based on that graph, I provided two statements. If the statements are not visible, I'll read the statements also. Just look at the statements. First statement, chromatic number of the above graph is 3. Chromatic number of the above graph is 3. The second statement, it does not have Hamiltonian cycle. So my intention is to cover two topics in this question. One is chromatic number, another one is Hamiltonian cycle concept. Okay. So आप try करो पहले. आप ध्यान से सुनो and see what is the strategy we are applying for solving each and every question, and also see how much time we are taking for solving each and every question. Here time is also very important. Okay. "30 seconds already completed." Yeah, most of you are responding in the chat box. I'm very happy. You have another 30 seconds more. Satyam, Sadiq Paul, Amrita Yadav, Kundan Kumar. So everyone is responding in the chat box. Shrijal Patel, Hari Krishna Reddy. Okay, let me explain what is the basic concepts involved in this question, friends. First, let me define what is chromatic number. Chromatic number is nothing but minimum number of colors are required to color the vertices of a graph such that no two adjacent vertices have the same color. The minimum number of colors are required to color the graph vertices such that no two adjacent vertices have the same color. That is called vertex coloring problem. Of course, same concept will be applicable for edge coloring also. Alright, friends. So here they are expecting how many minimum number of colors are required to color these vertices. Generally, whenever they come across question based on chromatic number, students are trying to paint the vertices. Each and every vertex they will find answer either 2 or 3 or 4. Okay. But अब ध्यान से सुनो, a strategy very simple in this case. You never used to paint vertices on the graph if they ask question in the GATE paper. Okay. Whenever they ask question on the chromatic number or independent set, definitely that graph must be some standard graph, friends. You should identify what is a graph. Okay. If you observe this graph clearly, so here just observe the cycle. Here it is 4. The length of the cycle is 4. Here also the length of the cycle, just observe, friends, here. It is one edge, it is second edge, it is third edge, it is fourth edge. So its cycle length also 4. And if you consider the cycle length like 1, 2, 3, 4. Now I understood the concept, very simple. The strategy is very simple. The graph contain all cycles of length 4. It means that the graph contains all cycles of even length. If the graph contains all cycles of even length, definitely that graph is bipartite graph. If the graph is bipartite graph, how many minimum number of colors are required to color the graph? Only 2. Right, friends? If the graph is bipartite graph, then minimum number of colors required to color the graph is only 2. Okay. So what is the strategy for solving this question? Very simple. Graph contains all cycles of even length. If the graph has all cycles of even length, it becomes bipartite graph. If the graph is bipartite graph, then minimum number of colors are required only 2. But here they provided how many? 3. Therefore, hence first statement is wrong. Chromatic number of the above graph is 3 is not correct. So what is the chromatic number of the above graph? That is only 2. Okay. The chromatic number of the above graph is only 2. Therefore, first statement is wrong, friends. First statement is wrong. Now they are talking about it does not have Hamiltonian cycle. Again, whenever student come across this question, their thought process is they are trying to find Hamiltonian cycle. Hamiltonian cycle concept क्या है? Every vertex must be visited exactly once. Every vertex must be visited exactly once and return to the starting vertex. While doing this process, you may skip some edges also, no problem. But every vertex of the graph must be visited exactly once and return to the starting city. That is called Hamiltonian cycle. So whenever they come across this type of graph, they are trying to find cycle in the graph. But the answer और एक बार, if they ask Hamiltonian cycle or chromatic number or independent set or vertex covering, whatever it may be, definitely that graph must have some standard properties. Some standard properties. Now we identified it as a bipartite graph, friends. We identified it as a bipartite graph. What is the meaning of bipartite graph? If the graph G is equals to V comma E is a bipartite graph, the graph G is equal to V comma E is a bipartite graph, then this vertex set V will be partitioned into 2 disjoint vertex sets. Okay, we can name them as M and N. Alright, such that M plus N must be equals to V. V number of vertices are partitioned into 2 disjoint sets, name them M and N, such that M plus N must be equal to V. Now what is the relationship between bipartite graph and Hamiltonian cycle? Very simple, friends, very simple. We can ensure that there exists Hamiltonian cycle in a bipartite graph provided cardinality of M must be equals to cardinality of N. That is minimum requirement. Okay, I am repeating once again. The minimum requirement for existence of Hamiltonian cycle in a bipartite graph is cardinality of M must be equal to cardinality of N. Means as many vertices are there in the set M, those many vertices must be there in the set N. Clear, friends? That is a basic funda. But in this question, if you observe, total how many vertices आपके पास? 11 vertices, which is odd number. If it is odd number, how can I divide them into 2 equal parts? Is it possible to divide them into 2 equal parts? No. Alright. If you observe, how can I say it is a bipartite graph? Just observe this graph once. Look at this graph, friends. One is connected to 2 and 8, 9 and 3. Hence I can say that the vertex 1 in the set M and it is connected to 2, 1 is connected to 2, 1 is connected to 8, 1 also connected to 9 and 1 also connected to 3. Right, friends? Okay. So next, if you take 2 connected to 1 already completed. Okay. Let me take another vertex, like suppose 5 connected to 2 and 5 connected to 1, right? Sorry, 5 connected to 8. So obviously 5 must be here, right? So 5 connected to 2 and 5 connected to 8 and 5 connected to 10. So 10 must be here, right? 10 must be here. The next, if you are talking about 4 connected to 2. So since 4 connected to 2, definitely 4 must be in the set M, right? Next, if you take 3 3 connected to 1, hence 3 must be that set, okay. And if you take 6, 6 is connected to 3. So since 6 is connected to 3, 6 must be in the set M, right? And next, if you take 7, the 7 is connected to 9. So hence we can keep 7 is here. It means that M contains 5 vertices, whereas N contains here 1, 2, 3, 4, 5. So one more vertex is missing. Let me talk about that vertex is, I think it is, who is missing? 4, 5, 6, 7, 8, 9, 10, 11. So see here, 11 is connected to 6. So it means that 11 is here. Clear, friends? So we partition 11 vertices into 2 sets, where one set contain 5 vertices and other set contain 6 vertices. But the necessary condition that the bipartite graph is having Hamiltonian cycle is cardinality of M must be equal to cardinality of N, whereas here cardinality of M 5, where cardinality of N, which is 6, the basic property is not satisfied, hence it does not have Hamiltonian cycle. The statement is correct. So answer to this question is only 2, friends, okay. आज का सेशन बहुत इंटरेस्टिंग सेशन. Every question we will solve only by using strategy. We don't want to do any hard work. We will use only smart work for solving any question, friends. Okay. I hope you understood the strategy which I applied for solving this question, right? Let me move to the next question, friends. All right. This is a question number 3. If the font size is not visible, I will read it once, just look at here. Suppose G is a linear graph. Suppose G is a linear graph with 5 vertices as shown below. So I have drawn linear graph with 5 vertices named as V1, V2, V3, V4, V5. Let P of N is a polynomial in terms of N. Let P of N be the number of ways coloring the graph using N or fewer colors, okay, N or fewer colors, then P of N value equal to, okay. Take time and try and give me back the correct answer for this question. Sadhakpal, it is so simple. Sadhakpal, you are asking again how chromatic number is 2. It is a bipartite graph, right? Once it is a bipartite graph, only chromatic number is 2. I am sure every question you will learn some new concept in today's session, friends, okay. Alright, some of you are giving answer is C, some of you are giving answer is B. Sadak Paul, is it clear why chromatic number is 2 for the previous question? Yeah, Priyanshu Mangal, Ishwar Mahapatra. You have another 30 seconds time for completing this question. Right friends, first what is the strategy we are going to apply for solving this question? The strategy is so simple. Here they are talking about number of ways of coloring the graph. The different is P of n, right friends? P of n be the number of ways coloring the graph. First understand what is the meaning of coloring. Coloring is nothing but you supposed to color the vertices such that no two adjacent vertices have the same color. That's what we discussed in the class, right? You have to color the vertices such that no two adjacent vertices have the same color, right friends? Okay, let me try to understand this problem by substituting various values of n. So I am having total 5 vertices. Suppose if I take P of n, let me talk about P of 0. Try to understand what is the meaning of P of 0, friends. Okay, P of 0 is nothing but just substitute n is equal to 0 here. P of 0 is the number of ways coloring the above graph G using 0 colors. Clear? P of 0 be the number of ways of coloring the above graph G using 0 colors. Means if you don't provide any color, then how can you color this graph? It is not possible. Therefore number of ways is 0 only, right friends? Okay, next, if I take P of 1, try to understand, try to interpret what is P of 1. Please interpret what is P of 1. So substitute n is equal to 1 in the statement. P of 1 be the number of ways of coloring, the above graph G using only one color. Is it possible to color this graph with only one color? Suppose if I provide that one color is red color, just imagine that one color is red color. Yes, we painted this vertex with red color. We painted that vertex with red color. Then what about V2? We cannot paint V2 with red color, right? Because coloring is the concept such that no two adjacent vertices have the same color. So therefore, if I have only one color, I cannot color the vertices. Hence P of 1 also 0. If they provide only one color, I cannot color the graph, right friends? Okay. Let me take P of 2. P of 2. So what is the meaning of P of 2? Interpret the statement. P of 2 be the number of ways of coloring the above graph G using two colors. So if I provide two colors, how many ways you can color that graph? Let me take those two colors are red and blue, right friends? Okay. If you take two colors are red and blue, like here red, we can make it as blue, right? Here also we can make it as blue, and then it is red, and here it is red. This is one way to color the graph, right friends? Or else the second way to color the graph is I can make it as red color for V2, I can make red color for V4, right? And remaining vertices I can make it as blue color. Now verify the condition is meeting or not. Coloring is the concept such that no two adjacent vertices have the same color. If you observe this pattern, no two adjacent vertices have the same color. If you observe the below pattern, no two adjacent vertices have the same color. So if I have two colors, by using those two colors, I can assign colors in two different ways. Therefore, P of 2 must be equal to 2. P of 2 must be equal to 2. 2 ways, right? So once you understand the logic, simply substitute the values here, you can find the answer. Suppose if I substitute n is equal to 2, if I substitute n is equal to here, it will give 32, 2 power 5 means 32, which is not correct. If I substitute n is equal to here, 2 into 2 minus 1, that is 2 into 1 whole to the power of 4, that equals 2. So it may be correct answer, right? So if I substitute 2 n is equal to here, 2 into 2 minus 1, again it is also 2. So it may be correct answer, right friends, okay? Now P of n, here it is also may be correct answer. So we can eliminate only one option by using this strategy. So once you understand the process, now we can apply mathematical induction principle to solve this question. The strategy is very simple friends, just try to understand. If we have n colors in your hand, the starting vertex V1, how many ways we can color this one means, out of n colors I can choose one color. How many ways I can choose? That is nc1 ways, that equals to n. I can color n ways, right friends? And if I take V2, second vertex V2, total I have n colors. I have already chosen one color for first vertex, then the second vertex can choose any one of the color from the remaining n minus 1 vertexes. Here we are having n minus 1 colors. From those n minus 1 colors I can choose one, that is n minus 1, right friends, okay. Now what about third vertex V3? Now the answer is to know what is third vertex V3, how many choices are there? See totally आपके पास n colors है, right? First vertex n choices, second vertex n minus 1 choices because one color already assigned to V1. Then what about V3 means, again V3 also having n minus 1 possibilities. The reason is V3 will take any one of the n minus 1 color except the color which is assigned to V2. V3 will take any one of the n minus 1 color except the color which is assigned to V2, because it is a linear graph, right? It is a linear graph. Therefore V3 can take any one of the color except the color which is assigned to V2. Therefore it is also having n minus 1 possibilities, n minus 1 C1, that is n minus 1, right? Now what about V4? V4 also will take n minus 1 colors, right? N minus 1 colors, because there are total n colors are there. Then V4 will take any one of the n minus 1 colors except the color which is selected for V3. Therefore it is also having n minus 1 C4, sorry, n minus 1 C1, that is equals to n minus 1, right friends? So similarly V5 can take any one of the n minus 1 colors, okay, except the color which is assigned to V4. Therefore V5 is also having possibility n minus 1 C1, that is equals to n minus 1, alright. Let me explain once again. Total n colors are available. First vertex we can choose any one of the color. So out of n colors we can choose one color in nc1, that is n ways. Then the second vertex can take any one of the n colors except the color which is assigned for V1. Therefore n minus 1 choices, that's why written n minus 1. Third vertex can take any color except the color which is assigned for V2. Therefore it is having n minus 1 choices. Continue the same process till V5. Now what is your total task? Your total task is assignment of colors to the vertexes such that no two adjacent vertices have the same color. So the task will be completed by completing subtask V1, subtask V2, subtask V3, subtask V4, subtask V5 one after another. It means that the total task will be completed if you complete this subtask one after another. Then tell me what type of principle you have to apply here. Obviously product rule, alright. In the combinatives we are having product rule. If the whole task will be divided into some subtasks, and if you complete subtask one after another, then the total number of ways to complete the whole task is equals to, you have to multiply the number of ways for completing subtasks. Therefore here n into n minus 1 into n minus 1 into n minus 1 into n minus 1, which is nothing but n into n minus 1 whole to the power of 4. Hence answer to this question is option B is correct. Alright friends, okay. These subtasks must be completed one after another, hence I applied product rule. So by using product rule, it should be n into n minus 1 whole to the power of 4. So इसका अंदर strategy क्या है? Very simple. The first vertex how many colors are required, and the second vertex how many colors are required, and third vertex how many colors are required, like that. Afterwards we applied product rule. So this problem related to coloring concept, but we adapt the concept of combinatoric concepts here, right? So this is a way you have to apply from one concept to another concept in the question, right friends? I hope you enjoy this question. I really like this question. If anyone is having doubt, please ask me in the comment box. Yeah, thank you Raman Singh. It's a very nice question. अब सभी लोगों ध्यान से सुनो, आज का क्लास बहुत इंटरेस्ट है. If you like the concept, you should comment in the comment box, friends. Let me go to next question without wasting time. Yes. This is also a little bit tricky question. I'll read the question if the font is not visible. Please listen. Which of the following statements is or are true for any connected planar simple graph? Any connected planar simple graph where that graph contains E number of edges, V number of vertices, where minimum required number of edges must be greater than 1. And the first statement is E less than or equal to 3V minus 6. And the second statement is there is a vertex V of the graph G such that degree of V is at most 5. Okay, degree of V at most 5. Then which of the statements are true? अब पहले ध्यान से सुना और एक बार. See what is the concept involved in the question. First try to identify the concept, friends. Okay. Thank you, Aishwarya Dash. Yes, Suhana Sharma. You have another 30 seconds time for solving this question. So most of you are giving response in the chat box. Alright friends, the time allotted for this question is over. See, first observe how the thought process is there for solving this question. Okay, the moment if you see this question, so where we will start the process? The process is so simple. Here they mentioned is a connected planar simple graph. So whenever they mention connected planar graph, immediately you have to recall standard formula, that is Euler's formula. First you write that Euler's formula. Okay, so first write that Euler's formula. Euler's formula says that number of vertices plus number of regions must be equals to number of edges plus 2. This is standard Euler's formula. That is standard Euler's formula. But if you observe this statement, that formula in the inequality consists only edges and vertices. The formula in the inequality consists only edges and vertices. Means immediately you have to think that you have to convert this formula only in terms of vertices and edges. Right friends, you have to convert this formula only in terms of vertices and edges. Right, means we have to replace regions, in terms of number of edges. Then think about the relationship between region and edges. We have a theorem is called sum degrees of region theorem. Right, what is sum degrees of region theorem friends? Just recall sum degrees of region theorem. Sum degrees of region theorem says that summation I runs from 1 to n, degree of every region, if you sum up all the values, it must be equal to 2 times of number of edges. 2 times of number of edges. So if I know the degree of every region, I can convert number of regions. Within terms of number of edges. Then the formula will be converted in terms of vertices and edges. Let me see. Here one important condition is, in a planar graph, especially in a planar graph, degree of every region is at least 3. In a planar graph, degree of every region is at least 3. Tell me, what is the definition of planar graph? Planar graph is nothing but we have to draw a graph on a plane such that no two edges cross with each other. Example, if I draw a planar graph like this, so far it is planar, right? I can draw an edge from here to here like this. You feel that it is not a planar, but we can make it is planar by drawing edge like this. It is planar, right friends? Now observe, it is one region. We can call this region is R1, this region is R2, and this region is R3. Outside unbounded region is R4. If you observe, every region is having, or every region is bounded by at least 3 edges. Every region is bounded by at least 3 edges. Look at here. This region bounded by 3 edges, this region bounded by 3 edges, right friends? And R3 also bounded by 1, 2, 3, right? So at least three edges are there. It means that degree of every region in the planar graph is at least 3. Okay, so please try to understand. So minimum degree of every region is at least 3. Okay, so we have one formula, that is minimum degree of the graph denoted by small delta, right friends? Okay, small delta of G, and maximum degree denoted by capital delta of G. It is valid for both region and vertices also. Okay, then minimum degree of the graph always less than or equal to average degree of the graph always less than or equal to maximum degree of the graph, right? That minimum degree of the graph small delta of G, how you will get average degree? Means sum of the degrees of all vertices by total number of vertices. But sum of the degrees of all vertices means 2 times of edges by using handshake lemma, right? And the total number of vertices here, which is less than or equal to capital delta of G, right friends? Okay. Therefore, minimum degree of the graph must be less than or equal to 2 times of E into V. So if I bring this one cross multiplication, small delta of G into total number of vertices less than or equals to 2 times of edges less than or equals to capital delta of G into total number of vertices. Here we applied this formula for vertices. Similarly, we can also apply this formula for regions. Okay. So for region also, minimum degree of the graph into number of regions must be less than or equal to 2 times of edges less than or equals to maximum degree of the regions into total number of regions. Okay, here we applied for vertices, the same formula applicable for regions also. The strategy is so simple friends. Our ek baat the answer is no. Sum of degrees of all regions must be equal to 2 times of edges, right? Suppose the minimum degree of the vertex is small delta of G, maximum degree of the vertex is capital delta of G, then it must satisfy this condition for degrees of vertices. The same condition also true for degrees of regions. Okay. Therefore, small delta of G into number of regions less than or equals to 2E less than or equal to capital delta of G into number of regions. What is small delta of G? Minimum degree of the region. Minimum degree of the region. But in planar graph, minimum degree of region is 3. Therefore, I can take it 3 into minimum degree of the region 3 into R. 3 into R must be less than or equal to 2 times of edges, right? Therefore, I will write that statement now. Look at here. So since it is a planar graph, in a planar graph, minimum degree of region is 3. Therefore, 3 into number of regions must be less than or equal to 2 times of number of edges, right? Do you know why we are writing all these statements? Only we want to convert that formula into in terms of vertices and edges. From here we can write is number of regions must be less than or equal to 2 by 3 into number of edges. So replace number of region value in this formula. Okay. So number of vertices they mentioned small v plus number of regions we got here it is 2 by 3 into number of edges, but number of edges they mentioned is E number of edges, hence it is E. On the right hand side we are having E plus 2, E plus 2. Now up the answers to know, actually if you take number of regions R, you will get equality symbol. But in the place of number of regions R, I have taken 2 by 3 into E, which is larger than number of regions. Since I am substituting larger value in the place of R, definitely left side value is more than the right side value, right? So it must be greater than or equal to. Or ek baar no, in the place of R, I am substituting larger value. If I substitute larger value on the left hand side, we will get more value than the right hand side, right? But the statement says that E less than or equal to 3V minus 6. Let me check is it possible or not. Simply bring it to that side, right? V greater than or equals to E minus 2 by 3, obviously we will get E by 3 plus 2, right friends? Okay. Now take cross multiplication here, 3 into V, here 3 into 2 6, that equals 3V minus 6 greater than or equal to E, which is a required condition for this statement, right? E less than or equal to 3V minus 6, hence this statement is true. Okay, first statement is true. We will check second statement. आप कॉपी करो पहले. But what is the basic strategy for solving this question? Very simple. Euler's formula is the strategy which I applied for this question. You take any Suraj, you take any planar graph, minimum degree of the region is at least 3. Ishwar Mahapatra, you take any planar graph, minimum degree must be 3. If you have understood this problem, just type in the chat box understood, or something you can type clear in the chat box, so that we will move to next question. Right. Okay friends, okay. If you are unable to copy this topic, okay, you can also watch this video after completion of live class, because they are going to upload in the YouTube. So please allow me to teach more number of questions in the given time. Okay. Now let me justify is this statement is true or not. There is a vertex V of G such that degree of V is at most y. Means if you take planar graph, in a planar graph definitely there exists a vertex V such that degree of V must be at most 5, at most 5. So how I am going to prove this statement? So I will take proof by contradiction method, very simple, it is standard statement only. First what I will assume that there does not exist a vertex V of G such that degree of V at most 5. I will take there does not exist vertex V such that degree of V is at most 5. With that I will take Euler formula, and at the end I will show that Euler formula is fail. So if the Euler formula fail, our assumption is wrong, hence there exists a vertex whose degree is at most 5. That is a strategy which I am going to apply. It is a standard problem, that's why I don't want to waste your valuable time. I will directly explain the proof, just see the proof friends. Right, just observe how did I take this statement. Suppose if each vertex has degree greater than or equal to 6, actually they are asking that there exists a vertex V such that degree of V is at most 5, at most 5. So I want to take proof by contradiction, that's why I am taking like this. Suppose if each vertex has a degree greater than or equal to 6, means it is nothing but at least 6, correct friends, at least 6. Now just now we discussed one formula. If the minimum degree is small delta of G, then small delta of G into number of vertices must be less than or equal to 2 times of number of edges, correct. So if every vertex having degrees at least 6, then 6 into V, 6 into total number of vertices must be less than or equal to 2 times of edges by using this formula. Right friends, okay. From this I can find V value less than or equal to E by 3, right. Here we have to recall this formula, sum of degrees of all vertices must be equal to 2 times of edges. Now I am taking Euler formula, alright. So vertices, number of vertices plus number of regions must be equal to number of edges plus 2. But in the place of number of vertices, I can take this inequality. Therefore number of edges by 3. Since it is a connected planar graph, we already proved that number of regions must be equal to 2 by 3 into E in the previous slide. Just look at here. Just look at here. Number of regions value in a connected planar graph, number of regions must be 2 by 3 into E, right friends, okay. So therefore I substituted V value cardinality of E by 3, I substituted R value, that is 2 by 3 into E, right. So since I am substituting larger value than the number of vertices, and since I am substituting larger value than the number of regions, therefore this equal to symbol becomes greater than or equal to, because left hand side we are substituting larger value, right. So simplify it, we will get cardinality of E greater than or equal to cardinality of E plus 2. So from this if we bring cardinality of E left side, we will get 0, 0 greater than or equal to, but 0 greater than or equal to is not true. We got contradiction because of our assumption is each vertex having degrees at least 6. Therefore, our assumption is wrong. If our assumption is wrong, there exists at least one vertex. Our assumption is wrong, there exists a vertex v of g such that degree of v less than or equal to 5. Friends, these are standard properties. So, before entering into the exam hall itself, you must be able to recognize these properties and you have to answer very quickly in the exam hall. Okay? In the GATE examination hall, you do not try to prove mathematically because you do not have that much amount of time. Yeah. Suraj Anand, just recall formula once again. Any planar graph, minimum degree of the region must be 3. Minimum degree of region must be 3. You take any planar graph, minimum degree of the regions must be equal to 3. So, whenever they are talking about connected planar graph, immediately you have to recall Euler's formula. Definitely they will ask only applications based on Euler's formula only. If you could refer previous year GATE questions, there are so many questions came from Euler's formula. You try to understand the importance of Euler's formula, friends. Okay. This year also I am expecting one question from Euler's formula. I hope you have already copied. Let me move to the next question. Question number 5. Which of the following statement are true? I gave two statements. The first statement, if G is a simple graph with 20 vertices, if G is a simple graph with 20 vertices such that the degree of each vertex is at least 10, then G has a Hamiltonian circuit. Second one, if G is a simple graph with 20 vertices such that degree of u plus degree of v greater than or equal to 20 for every pair of non-adjacent vertices u comma v, then G has a Hamiltonian circuit. Then which of the statements are true? Thank you, Rajak. Thank you, Akshay. Thank you, Anasuya, Mohapatra, Raman Singh, Ajay. Yes, most of you are giving correct answers. Very nice. So we don't want to waste much time for this question, friends. The first try to understand whenever they are talking about the graphs, okay, whenever they are talking about graphs with several number of vertices, it don't try to draw the graph with those many vertices, friends, okay. Definitely there exists some hidden standard property for solving this question. You should understand what is standard property for solving that question, right, friends, okay. Here the strategy is very simple. See, here they are talking about Hamiltonian circuit. They are talking about Hamiltonian circuit. So whenever they are talking about Hamiltonian circuit, first recall what are the standard theorems are available for proving the given graph is having Hamiltonian circuit or not. Your thought process must start from there only. Okay, don't try to draw the vertex which is having 20 vertices and don't do any calculation, friends. Straight away you think what are the standard properties are there for solving Hamiltonian circuits. Obviously we are having two important theorems which I mentioned in the class. One is called Dirac's theorem, another one is called Orr's theorem, right. Dirac's theorem, another one is Orr's theorem. So recall Dirac's theorem. What Dirac says that? So Dirac says that if degree of every vertex is at least n by 2, if degree of every vertex is at least n by 2, then that graph must have Hamiltonian circuit. But converse need not be true, right? But converse need not be true, right? So if the graph is having n vertices, if the degree of every vertex is at least n by 2, then there is 100% guarantee that graph must have Hamiltonian circuit. That is called Dirac's theorem. Let me show the statement once, you will get clear idea. Look at here, friends. A simple graph with n vertices where n greater than or equal to 3 and minimum degree is at least n by 2, then it must have Hamiltonian circuit. Clear, friends? Now go back to the question. Here there are 20 vertices are there and each vertex having at least degree of each vertex at least 10, which is nothing but n by 2. Hence the statement is true, friends. The statement is true, right? Next one, which is Orr's theorem. Orr's theorem. This theorem says that if you take a simple graph G, right, and if you take two vertices u comma v, where u and v are non-adjacent, and if they satisfy the condition degree of u plus degree of v greater than or equal to n, right, for every two non-adjacent vertices, if this condition satisfies, then that graph must have Hamiltonian circuit. But converse need not be true. Means if the graph is having Hamiltonian circuit, this condition may or may not be satisfied. But if this condition is satisfied, that graph must have Hamiltonian circuit. That is proved by Orr's. Okay, that is called Orr's theorem. Clear, friends? Okay. So if you want, you can write down these two theorems. Just take snapshot if you want. So by using these two statements, go back to this question. Here we are having 20 vertices and degree of u plus degree of v greater than or equal to 20, which satisfy the requirement of Orr's theorem. Hence both the statements are true, friends. Both statements are true. Answer this question, both statements are true. If you want, you can copy Dirac's and Orr's theorem. Yes, Malina Sahu, you are right. I'll move to next question. The question number 6. If the font is not visible, I'll read the question. Consider the following statements. There exists a connected simple planar graph with 10 vertices 16 edges and 8 regions. 8 regions. This is the first statement I provided. Second statement, a connected planar graph is a polyhedral graph if degree of R greater than or equal to 3 for each region R belongs to R of G, and degree of V greater than or equal to 3 for each vertex V belongs to V of G. Right? Means a connected planar graph is said to be polyhedral graph if it meets these two conditions: degree of R greater than or equal to 3, degree of V greater than or equal to 3. Then there does not exist a polyhedral graph with exactly 7 edges. Then there does not exist a polyhedral graph with exactly 7 edges. We want to verify whether the statement is true or not. Third one, if the graph G is not connected, then G bar is connected. Okay. Check these 3 statements and tell me which is the correct answer. No, Rajak, circuit and cycle, they are not same. Uplab Rajak, circuit and cycle, they are not same. Please just refer class notes or any other online resources to know the difference between circuit and cycle. It is not the right place to discuss those concepts now. First option only 1 and 2, second option only 2 and 3, third option only 1 and 3, fourth option all the above. In each question I am able to covering minimum 3 concepts, friends, minimum 3 concepts. That's why this session is very much useful. It covers almost all topics of the discrete mathematics. Right, most of you are providing answer is C. Let me check whether C is correct answer or not. So the first one is very simple because it's standard property. To verify this one, we can take Euler's formula. Euler's formula says that number of vertices plus number of regions must be equal to number of edges plus 2. So here number of vertices are 10, number of edges are 16, number of regions are 8. Just substitute them here. 10 plus 8 is equal to 16 plus 2. Since it is satisfied Euler's formula, therefore there exists a connected simple planar graph with the vertices, which is correct, right friends? Okay. Next, second one, a connected planar graph is called polyhedral graph if degree of every region is 3, at least 3. If degree of every region is at least 3. Now please recall the properties just now we covered. If degree of every region is at least 3, it must satisfy the condition 3 into number of regions must be less than or equal to 2 times of number of edges. Right friends, okay? And the second condition, degree of each vertex is at least 3. So therefore 3 into number of vertices must be less than or equal to 2 times of number of edges. Clear? But here they are asking there does not exist a polyhedral graph with exactly 7 edges. Now also we will take this problem by taking proof by contradiction. Proof by contradiction. So what I assume that, just assume that there exists a polyhedral graph with exactly 7 edges. Assume that there exists a polyhedral graph with exactly 7 edges. You just take assumption. Okay. If there exists polyhedral graph with exactly 7 edges, then in the place of E, I can replace with 7 edges, right? Let me change the font color, maybe it is not visible for you. Just assume that total number of edges you consider is 7. Assume that total number of edges you consider is 7. Then it is 3 into number of regions must be less than or equal to 2 into 7, that is 14, right? So 3 into number of regions must be less than or equal to 14. Then what is the maximum value of R? What is the maximum value of R? Can I take number of regions are 5? Can I take number of regions are 5? Suppose if I take number of regions are 5, 3 into 5, 15. 3 into 5, 15. 15 less than or equal to 14, which is not correct, right? Then maximum value of R is 4 only, right? So therefore, to satisfy this condition, maximum value of R must be 4 only. Maximum value of R is 4. I am taking it directly 4. So if I take directly 4, so here 3 into 4, okay, means number of regions you can take maximum 4. So let us assume that maximum number of regions are 4. Maximum, just assumption that, right? So similarly 3 into V less than or equal to 2 into E, therefore 3 into number of vertices must be less than or equal to E means here 7, so that is 14. What is the maximum possible value of number of vertices? Again 4 only, right? Therefore let us assume that number of vertices maximum 4, because the reason is here we will take maximum is 4, right? Directly I am taking straight away V is equal to 4. Now apply Euler's formula. Euler's formula says that number of vertices plus number of regions is equals to number of edges plus 2 for connected planar graph. If you take maximum number of vertices are 4, here we will get 4. If you take maximum number of regions are 4, you will get 4, and the number of edges which I have taken it is 7, that is 7 plus 2. Now LHS I am getting 8, RHS I am getting 9. LHS left hand side I am getting 8, right hand side I am getting 9. Obviously 8 equal to 9 is not correct. Obviously 8 equal to 9 is not correct. So we got contradiction. Do you know why we got contradiction? Because we have taken number of edges equal to 7. So if you take number of edges is equal to 7, definitely Euler's formula get fail. Therefore, in a polyhedral graph, there does not exist exactly 7 edges. Okay, there does not exist polyhedral graph with exactly 7 edges. If there exists a polyhedral graph with exactly 7 edges, then Euler's formula get fail. But Euler's formula is standard formula, right friends? Okay, therefore there does not exist polyhedral graph with exactly 7 edges. Okay, I hope you enjoy this question. It's very interesting question. Okay, so therefore this statement is also true. A connected planar graph which is a polyhedral graph, then there does not exist a polyhedral graph with exactly 7 edges. If you think it is existing, then Euler's formula get fail. Therefore the given statement is correct only. So second statement is also correct, right friends? Third statement, it is standard problem. Third statement is standard problem, we already discussed in the class. If G is not connected, then obviously G bar is connected. I don't want to waste time for this one. Okay, so this is standard. So answer this question is option D is correct, friends. Option D is correct. Most of you gave answers option C. Do you know why you gave option C? Because you don't know the analysis for option 2. You don't know the analysis for second statement. That's why you are giving answers option C. But in the GATE examination, negative marks also there, friends. Please try to understand. Okay, in order to get succeed in the GATE examination, you must have 3C. 3C. What is 3C? first you must have clear concept. Then second one, you must have conviction about that concept, whether it is true or false. Third one, you must have courage to answer that question with the concept. Okay, you know the concept but you don't have strong conviction, you cannot solve it. You know the concept, you have strong conviction but you don't have courage to answer it, still you will get negative marks only. Therefore, develop concept and you must have strong conviction and you must have courage to solve that question with the concept, friends. Okay, so since we know the basic concept of polyhedral graph, therefore all the three statements are true here. I hope you understood this question, right? Yeah. If you want beautiful handwriting for this question, I gave explanation here. If anybody want, you can copy it, friends. Okay. Just look at here. The same question I have written complete explanation. If anybody want, you can copy it. This is first one and it is second one, friends. आप कॉन्सेप्ट पसंद है तो आप कमेंट में लिखें. Thank you, Rajak. Malina Sahu, thank you. So it is a complete explanation for the previous question, friends. Okay. Thank you, Vijay Anand, Raman Singh. Kanishk, Anusaya Mohapatra. Right, I will move to the next question so that you will get chance for solving more number of questions, friends. Okay. Don't feel that I am teaching very fast, because this video also available in offline. You can copy it later. Okay. Yes. So far we solved questions based on graph theory. Now enter into the concept of set theory, friends. Okay. And this question based on equivalence relations. For x comma y and u comma v in R square, define x comma y related to u comma v if x square plus y square is equal to u square plus v square. Right, friends. So x comma y related to u comma v, there is small correction is required. It is if and only if, friends. It is if and only if. It is if and only if. So x comma y related to u comma v if and only if x square plus y square is equal to u square plus v square. Then which of the following is or true? First statement, R is an equivalence relation. R is an equivalence relation. Second statement, equivalence class of A comma B, equivalence class of A comma B is a set of points x comma y. Equivalence class A comma B is a set of points x comma y which forms circle with center 0 comma 0 and radius square root of c, where c is equals to a square plus b square. Now which of the above statements are true? The font is not visible. I will simply zoom out so that you will get more clarity. Yeah, Singh, Aman, Jubair, nice. So most of you gave correct answer. Have you already practiced this question? Right. So most of you give correct answer. I'm very happy. So why should I waste valuable time for this question, friends? Okay, let me explain quickly. Students who have not understood this question, you can easily answer it now. See, they're talking about R is an equivalence relation or not. Equivalence relation must satisfy three conditions: a reflexive, symmetric, and then transitive property. So first let me check whether it is satisfying reflexive property or not. Okay. So reflexive property means here x comma y related to again x comma y, then only we can say that it is satisfying reflexive property, right friends? But according to definition, xy related to uv if and only if x square plus y square equal to u square plus v square. So x comma y related to x comma y if and only if x square plus y square is equals to x square plus y square, which is true, right? So hence it is satisfying a reflexive property. Next we will check symmetric property. Symmetry property says that suppose if x comma y related to u comma v, just assume that x comma y related to u comma v, then we supposed to prove that u comma v related to x comma y. We supposed to prove this one. But whenever xy is related to u comma v, by using the given condition, we can write it as x square plus y square is equals to u square plus v square, right friends? Okay. We can also rewrite this equation u square plus v square is equals to x square plus y square. Hence u comma v related to x comma y. So therefore reflex is over, symmetric is also over. Transitive relation. Transitive relation, just assume that xy related to uv and uv related to w comma z. Right friends, if a related to b, b related to c, we suppose to prove that a related to c, means we want to prove that x comma y related to w comma z. We want to prove this condition. But according to definition, whenever this condition is true, we can say that x square plus y square is equals to u square plus v square, right? So whenever this condition is true, we can take u square plus v square is equals to w square plus z square. Clear friends? So x square plus y square is equal to u square plus v square, but u square plus v square equal to w square plus z square. So by combining these two, we can write it as x square plus y square is equals to w square plus z square, right friends? W square plus z square. It means that xy related to w comma z. Hence it satisfied all the three properties of equivalence relation. So that's why relation is called equivalence, right? Then how to define equivalence class? Please recall the definition of equivalence class. Equivalence class of X can be defined as set of all those elements Y such that Y related to X, like this. Okay, set of all those elements of Y set of all those elements of y which such that y related to x, that is called equivalence clause of x. Okay. So the proof I have provided here in the next slide. See, it is reflexive proof, symmetry proof, it is transitive proof. If anybody want, you can copy it, friends. Okay. Right. See, equivalence clause of a comma b, equivalence clause of a comma b will take set of elements x comma y, set of elements x comma y such that x comma y related to a comma b. But when x comma y related to a comma b, we can say x square plus y square must be equal to a square plus b square. It is called standard statement for circle, which is having center is 0 0 and the radius is square root of a square plus b square. Okay. It is equation for standard circle. X square plus y square equal to a square plus b square means it is a circle which is having origin is 0 comma 0 and the radius is square root of a square plus b square. Hence both the statements are true. Okay. Both the statements are true, friends. I hope no one is having doubt about this question, right? So let me move to the next question. Question number 8. For a comma b belongs to r minus 0. R minus 0 indicates set of all real numbers except 0. Means it is a comma b are non-zero real numbers. For a comma b belongs to non-zero real numbers defined by a related to b if and only if a by b belongs to rational number, right? A by b belongs to rational number. Then which of the following is are true? First statement, R is an equivalence relation. R is an equivalence relation. Second statement, equivalence clause of 1 is Q. Q means set of rational numbers. Third one, equivalence clause of square root of 3 equivalent to equivalence clause of square root of 12. Where equivalence clause square root of x means equivalence clause of x. Then which of the above statements are true? Please try it, friends. सूरज आनंद, और एक बार देखिए आपका आंसर. हरिकृष्णा रेड्डी, अमन कुमार, अमृता यादव, Anasuya Mahabatra, option A, only 1 and 2. Okay. अब ध्यान से सुनो एक बार. Here a comma b belongs to non-zero real numbers. A comma B belongs to non-zero real numbers. You have another 30 seconds time for solving this question. Right, the time allotted for this question is over. So just now we discussed equivalence relation. We want to verify whether it is satisfying a reflexive, symmetric, transitive property or not. Okay. So when it comes to reflexive property, so when we are talking about reflexive property, A related to A if and only if A by A belongs to rational numbers, which is correct, friends, right? Because they mentioned A comma B are non-zero real numbers. If A comma B are non-zero real numbers, then definitely A by A becomes 1. Is it correct or not? If A comma B are non-zero real numbers, then definitely A by A must be equal to 1. 1 is a rational number, hence this statement is true. Okay, reflexive property is satisfied. Next, symmetric property. Suppose let us assume that A related to B, friends. If A related to B, then obviously A by B belongs to rational numbers. A by B belongs to rational numbers. Then what we supposed to prove that? We want to prove that B related to A. We want to prove that B related to A. To prove that B related to A, we want to prove that B by A must belongs to a rational number, right? If you can convince that B by A belongs to rational number, then we can say it is satisfying symmetry property. Okay, observe how I am going to convince the statement. See, if A by B belongs to rational number, we can also write this from this statement. We can also write 1 by B by A. A by B can be written as 1 by B by A, right? So 1 by B by A belongs to a rational number. Can write A by B as 1 by B by A? Yes. So if 1 by B by A it belongs to rational number, means numerator is rational number, denominator also rational number. How can I conclude the denominator is rational number? Because both B and A they mention non-zero real numbers. If both A and B are non-zero real numbers, if denominator and numerators are looking like this, obviously numerator is rational number, denominator also rational number. Hence B by A belongs to Q. Therefore B related to A, friends. Okay, B related to A. So what I am trying to convince you, whenever A by B belongs to Q, we can write it is 1 by B by A belongs to Q. It means numerator is 1, denominator is also non-zero value because of this condition. Hence the denominator also belongs to rational numbers. Therefore it satisfies symmetry property. Now I want to prove that transitive property, friends. Okay, transitive property. So A related to B, it means that A by B belongs to rational numbers. If B related to C, it means that B by C must belongs to rational numbers. Okay, now I want to conclude that A related to C. I want to conclude that A related to C. So it means that we want to prove that A by C belongs to rational numbers. Now then how do I prove that A by C belongs to rational number? Very simple. This A by C I can write it as this. In order to get A by C, I can write like this: A by C as A by B into B by C. I am dividing and multiplying with B. But we know that A by B is a rational number from this statement, and we know that B by C is a rational number from this statement. Product of two non-zero rational numbers, again rational number. Therefore this total A by C also belongs to rational numbers. Clear, friends? Okay, so hence it is equivalence relation. Now let me talk about second statement. If anybody want proper proof, I have written proof here. After class is over, you can copy it like this. I written with beautiful handwriting, like it is reflexive, symmetric, right friends, okay, and a transitive property, right. So therefore it is called equivalence relation. Now second statement is very interesting. Look at here, equivalence clause of 1 is Q. Equivalence clause of 1 is Q. Let me explain how to get equivalence clause of 1. So they are talking about equivalence clause of 1. Equivalence clause of 1 means it will take set of all B such that B related to 1, where B belongs to set of all non-zero real numbers. Clear friends? Where B belongs to set of all non-zero real numbers. It means that which is equivalent to B according to given condition, A related to B if and only if A by B belongs to Q. Therefore B related to 1, it means that B by 1 must belongs to Q. B1 must belongs to Q. Therefore it will take all B's such that B by 1 belongs to Q. It means that it takes all rational numbers. Therefore this set gives all rational numbers, right friends. अब ध्यान से सुनो और एक बार. Here I mentioned equivalence clause of 1 is set of all rational numbers. 99% student they are keeping this answer is true, but in fact it is not true friends. It is not correct. So let me explain properly why it is not correct. It is taking all B such that B by 1 belongs to Q. It means that B must be rational number and 1 must be rational number. But here they clearly mention that A comma B are non-zero real numbers. If A comma B are non-zero real numbers, definitely B by 1 belongs to Q. It means that B by 1 belongs to Q where B is non-zero, because your set itself says that A comma B belongs to R minus 0. Therefore answer to this question is not Q. Answer to this question is Q minus 0. Here most of the students are doing mistake, okay. Therefore second statement is not correct. Equivalence clause of 1 is not set of rational numbers. Equivalence clause of 1 is set of rational numbers by excluding 0. By excluding 0, because you are talking about B is non-zero real numbers. I hope it is very interesting for you, right? Okay. Now let me take what about equivalence clause of square root of 3. If you take equivalence clause of square root of 3 friends, it takes set of all elements B such that B related to square root of 3, right? Square root of 3 where B belongs to set of all non-zero rational numbers. So which is equals to B such that B related to square root of 3 means this condition must be satisfied. This condition must be satisfied. So what is the condition? If A related to B, we can write A by B belongs to Q. If B related to square root of 3, then B by square root of 3 must be rational number. Must be rational number. So therefore equivalence clause of square root of 3 means B by square root of 3 belongs to Q. Right friends, okay. Now if it takes equivalence clause of square root of 12, which is nothing but it will take B such that B by square root of 12 belongs to Q, which implies that it will take set of all elements B by square root of 12 can be written as 4 into 3. If I bring 4 outside, it becomes 2. 2 into square root of 3 belongs to Q. But you already aware about B by root 3 belongs to Q, which is multiplied by 1 by 2. That is also rational numbers. Means all those elements which appear in square root of 3 also appear in square root of 12. Therefore these two equivalence classes are same. Hence we can say that square root of 3 equivalence class must be equal to square root of 12, because both equivalence classes contain same elements friends, same elements, okay. If you want, you can take proof here. Reflexive, symmetric, transitive, and then equivalence clause of x equal to y such that y related to x. Equivalence clause of 1 equal to a such that a related to 1, that is a by 1 belongs to q. It means that a such that a belongs to q, therefore q minus 0. Set of all non-zero rational numbers. Clear? Copy it, friends. Yes, Ravi Shekhar, this type of question they will ask in the GATE also, because if you see one of the GATE question, in one of the GATE question, Ravi Shekhar, you are talking about will they ask this kind of question in the GATE? Yes, they will ask, because in one of the GATE question they mention question like this. See, A related to B, I think. Just Ravi Shekhar, am I going to explain to you only? In one of the GATE paper they ask question like this: A comma B related to C comma D, if and only if something they mention like this: A plus D is equals to something like B plus C, or it is not original GATE question, just I am going to give hint for this one, or something like A plus, maybe it may be A plus C is equals to B plus D, for example. Just here my intention is to explain, in the GATE paper this R is most important here. Okay, if you take it is and, you will get wrong answer. If you consider R, you will get correct answer, right? It's a very tricky question. In the examination under pressure, you cannot think whether it is R or and symbol, right? In the same way, here they are asking Q minus 0. Q minus 0, it is compulsory. It is the identification of this kind of problems, very important. Okay, Ravi Shekhar, I am explaining to you only. So in some GATE question paper, it plays vital role whether it is R symbol or and symbol, right? Okay, in the same way, are you talking about set of rational numbers or are you talking about set of non-zero rational numbers? Very important for you. Okay, okay, आप preparation ऐसा हो सकता है compulsory. Okay, right, friends. This equivalence clause of root 3 and equivalence clause of square root of 2. Yes, is it clear, Ravi Shekhar? Thank you, Rasik Mishra. Thank you. Thank you, Anasuya. Every question I have taken utmost care while preparing. I want to explain how many of you are facing problems while solving the question. Ravi Shekhar, I hope you satisfied with this my explanation, right? Right. Let me move to the next question, friends. The question number 9, which I took from the functions concept. So here they provided two functions. I am going to write functions once again because they are not visible properly for you. F of x is equal to 3 to the power of 2x plus 1, where g of x is equals to 1 upon 2 log base 3 of x minus 1. They provide two functions. Then which of the following is true? First statement, the function g is equal to f inverse, means g is the inverse of f. Second one, f circle g of x not equal to g circle of f of x. Third one, f circle g and g circle f both are bijective. Fourth one, f is 1 1 and g is on 2. See, in one question I am covering all topics of functions, like first statement inverse, second statement composition of function, third statement composition of functions, right? And third statement is bijective function, fourth statement 1 1 and 2. So in single question we are able to covering all concepts of functions. Akshay, nice comment, Akshay. Thank you, Keshav Gaur, Raman Singh. You can read the multiple select question, more than one answer is available. Right friends, the time allotted for this question is over. Try to understand how I am going to answer this question. Okay. First, the strategy for solving this question is you have to understand how to compute inverse of a function. Apply group theory knowledge here. If A is an element of the group G and B is another element of the group G and E is the identity element in the group G, and if it satisfies the condition like this, A star E is equals to E star A is equals to A. Just observe friends, I am talking about group theory. In a group theory, if A star E is equals to E star A is equal to A, then E is called identity element. E is called identity element. Similarly, if A star B is equals to B star A is equals to E, then A is called inverse of B. A is called inverse of B, right friends? Okay, that is A is called inverse of B, which is denoted by, or B is called inverse of A, both of them. Okay, A and B are inverse with each other. Okay, so we can say here inverse of A is B, or we can say inverse of B is A. So if you could understand group theory concept properly, you can easily answer this question within fraction of seconds. Within fraction of seconds, friends. Let me explain how to answer this question within 30 seconds. Within 30 seconds. Just observe. Here A comma B are elements, where here F comma G are functions. Here operation is star, whereas here operation is circle, means function composition. Now recall that when do you say G is inverse of F? When do you say G is inverse of F? Look at this one. In the place of A, we can write it as F. In the place of star, we can write circle. And in the place of B, we can write it as G. F circle G is equals to G circle F is equals to E. E means identity element. Means you are talking about identity function. Identity function. Identity function we can define it as I. Identity function we can define it as I. Now recall the basic concepts of identity function. What is the meaning of identity function? Identity function का मतलब, suppose if we have set A, if I define a relation from A to A such that every element is mapping to itself, means X is mapping to X and Y is mapping to Y. Clear friends? So such type of function is called identity function. Such type of function is called identity function, right friends? Okay, if F circle G is equals to G circle F is equal to identity function, then we can say that G is called inverse of F, or F is called inverse of G. Clear? Whenever F circle G is equal to G circle F is equal to identity function, then F is inverse of G, G is inverse of F, then definitely both F circle G and G circle F must be bijective, because inverse will exist only if they are bijective, right? If F circle G and G circle F both are bijective, then F is 1 1, G also 1 1, F is onto, G is also onto. Hence all the statements are true, friends. If I can prove that F circle G is equal to G circle F is equal to identity function, if I can prove that F circle G is equal to G circle F is equal to identity function, then I can say that the function G is equal to inverse of F. Then I can prove this statement is false. This statement is false, and F circle G, G circle F both are bijective. If I prove this statement, definitely F circle G and G circle F both are bijective. If both are bijective, then F is 1 1, G is 1 1, F is onto, G is also onto. Okay, here they mentioned F is 1 1, G is onto, which is all satisfied. But let me check, is it really F circle G is equal to G circle F is equal to identity function or not? Okay, let me check F circle G is equal to G circle F is identity function or not. But see, the moment if you see the question, first identify the concept. The concept is simple, friends. Find the composition. If the composition value is identity function, then one function is inverse of other function. If one function is inverse of other function, obviously F circle G is equal to G circle F, is concept is true. If they are true, F circle G must be bijective, G circle F must be bijective. Then F is 1 1, G is 1 1, F is onto, G is also onto. So by answering only one statement, you are able to eliminating remaining statements. Okay, let me find what is F circle G for this, friends. Okay. Sorry. Right. So first I am going to find G circle F of x, which is equal to G of f of x, which is G of, what is f of x, friends, here? That is 3 to the power of 2x plus 1, right? Now G of x, they define 1 by 2 into log base 3 of x minus 1. In the place of x, we are having 3 power 2x plus 1. Therefore 1 by 2 into log base 3 of, in the place of x, we are having 3 power 2x plus 1. Therefore we can write 3 power 2x plus 1. That is in the place of x. And minus 1, we can take minus 1. Then minus 1 plus 1 get cancelled, right? We'll have 1 by 2 into log base 3 of 3 power 2x. By using basics of logarithms, we can bring 2x here. Log 3 base 3 value is 1. Therefore, which is equal to 1 by 2 into 2x. Hence it is x. It means that G circle F is mapping element x to whom? It is mapping element x to x. Therefore G circle F is providing identity function. Clear, friends? If G circle F is identity function, definitely G is inverse of F or F is inverse of G. Clear? So if G circle F is identity function, now if we calculate F circle G also will give identity function. Therefore first statement is true, but here they mention F circle G not equal to G circle F, which is false, right? Since F circle G, G circle F giving identity function, therefore we know the basic concept. F is invertible if and only if F is bijective. F is invertible if and only if F is bijective. So G circle F is bijective here, right? So therefore F circle G and G circle F both are bijective functions. Okay. So F is 1 1 and G is onto. Not only that, friends, we can also write G is also 1 1, G is also 1 1, and F is onto. It is also correct. If you want, you can write this point also. Okay, it is also correct. Therefore, except second statement, remaining all three statements are correct, friends. But basic funda for solving this question is very simple. If you understand G circle F is equal to identity function, then G circle F and f circle g both are same and they are bijective, then one function is inverse of other function. I hope you like the explanation. Okay. So this explanation which I provided here, same concept friends. Okay, this is a basic theorem which is involved in this problem. Fx to y, gy to x, the function g is equal to f inverse only if g circle f is equal to identity function and f circle g is equals to identity function. So this is a diagram, if you want you can copy it friends. Okay. Yes, Ishwar Mahapatra, yes, it is correct. That's what I have written Ishwar Mahapatra here. Just look at here. Yes, 134 is correct answer. Shall we move to the next question friends? Right. These videos are also going to upload in YouTube channel. If you want you can watch it once again, you can copy those topics friends. This explanation for the same question. Right, next question. We enter into group theory. I took only one question to explain all concepts of function. So far we covered combinatorics concepts and graph theory concepts. So currently we are discussing set theory concepts friends. Right. Can you answer this question? Thank you Shiva Agrawal, Ishwar, thank you. Yes. It is straightforward question friends. We don't want to waste our valuable time for straightforward question. These questions are called recall based questions. In the GATE examination point of view, there are 4 kinds of questions they will ask. Recall based questions, analytical based questions, application based questions, comprehensive based questions. Recall based questions means if you remember formula you can answer the question. So this question related to recall based question friends. Okay. Look at here, what is the basic concept in this problem? If G is a cyclic group of order 31, so 31 is a prime number friends, 31 is a prime number. If the group is a prime order group, the group is a prime order group, then every group of prime order must be cyclic. Okay, every group of prime order must be cyclic. So for example, see, if order of G is equals to P, where P stands for prime number, then G must be cyclic. Then how many generators are there in the cyclic means P minus 1 generators are there, P minus 1 generators. So since there are 31 is a prime number, therefore number of generators must be 31 minus 1 will have 30 generators friends. Okay, answer is 30. The required formula for this one which I have written here, see, if G is a cyclic group of order n, the number of generators in G equal pi of n, where n can be expressed as P1 to the power of alpha 1, P2 to the power of alpha 2 and so on Pn to the power of alpha n, where P1, P2 up to some Pn are distinct prime numbers and alpha 1, alpha 2, alpha 3 up to some belongs to natural numbers. This is the formula for finding pi of n which I already covered in the class. If n is a prime number, pi of n is equals to n minus 1, hence 30 generators are possible. Yes, please copy it afterwards. Okay. Next question. This is also group theory related question. G is equals to Z comma plus is an infinite abelian group, then which of the following statements are true? First one, G is a cyclic group. Second one, if H1 is equal to 2Z comma plus, H2 is equal to 3Z comma plus, both are subgroups of G, then H1 union H2 is also subgroup of G. Okay. If H1 comma H2 are subgroups of G, then H1 union H2 is also subgroup of G. Then which of the above statements are true, friends? In this question, I am going to cover cyclic group concept and subgroup concept. Yes, Aman Raman Singh, Jubair. Malina Sahu, Srinivas Veliganti, can you check it once? Ashutosh Roy, right? Alright, let me explain, friends. So whenever we are talking about cyclic group, verify the operation which you are performing on the given group. Here the operation which we are performing, it is addition operation, friends, addition operation, right? So there are two definitions are available for cyclic groups. One is with respect to multiplication operation, another one is with respect to addition operation. Let me talk about this problem. If G comma dot is a group, and if you write G is equals to a power n such that n belongs to set of integers, and a belongs to G. If you could express G as a power n, then we can say that G is cyclic group generated by A. This is a definition with respect to multiplication. So with respect to addition, if G is a group with respect to addition, if we can express G is equals to n times of A such that n belongs to Z and A belongs to G, then we can say that G is cyclic group generated by A. When it comes to multiplicative group, it should be A power n. When it comes to additive group, it must be n into A. Now I want to generate complete set of integers. With the help of A. Then A is called generator of the G. Let me check which element is possible. Very simple, friends. Suppose if A is equals to minus 1, just imagine if A equal to minus 1, then G is equals to minus 1 into n, or n into minus 1, such that n belongs to integers. Now your set is set of integers, right? Then how we are going to generate set of integers now? Set of integers Z is equals to minus 3, minus 2, minus 1, 0, 1, 2 and so on like this. We want to generate complete set with the help of minus 1. Very simple. If put n is equal to 0, 0 into minus 1 you will get 0, right? If put n is equal to 1, 1 into minus 1 you will get minus 1. If put n is equal to 2, 2 into minus 1 you will get minus 2. If you put n is equal to minus 1, minus 1 into minus 1 you will get plus 1. If you put n is equal to minus 2, minus 2 into minus 1 you will get plus 2. It means by using minus 1 I am able to generate all the elements of the group. Therefore G is generated by minus 1, and minus 1 is called generator of the given group. Similarly, if I take A is equals to 1, then G is equals to n into 1, such that n belongs to Z. N belongs to Z. Clear, friends? N belongs to Z. So in this case, if you take n is equals to 1, we will get 1. N is equal to 0, we will get 0. If you take n value negative value, you will get negative values. Therefore, Z comma plus is a cycle group. How many generators are there? 2 generators are there. Okay. One is -1, another one is +1. Maybe in the GATE exam they may ask how many number of generators are there in a infinite cyclic group Z comma plus. How many number of generators are there in a infinite cyclic group Z comma plus. So number of generators in infinite cyclic group Z comma plus is -1 comma +1. Okay. The clear explanation I have written in the next page. Just look at here, friends. See here. Everybody look at here. G is equal to Z comma plus. It is a given set G, set of integers. By cyclic group definition with respect to plus, it should be NA. So A is generator of G, right? Therefore -1 and +1 both are generators of the G, because by using -1 +1 we are able to generating all the elements, right? Therefore hence G is a cyclic group. Now second one, they provide H1 is equals to 2Z comma plus. 2Z comma plus means 2 times of integer set. So every element in this set must be multiplied by 2. Therefore 2 into -3 -6, 2 into -2 -4, 2 into -1 -2, right? 2 into 1 2, like that they covered 2Z comma plus. It is called 2Z comma plus. Similarly 3Z comma plus means you have to multiply with 3 for the given set. Afterwards, if we perform union H1 comma H1 union H2, we will get the set. Now I want to verify whether union is subgroup of the given group or not. We have already discussed that union of two subgroups need not be subgroup. Union of two subgroup need not be subgroup. So once I use need not be subgroup, there is a possibility it may be subgroup also, right? There is a possibility it may be subgroup also. Therefore I cannot directly say it is not a subgroup. I have to verify it. I have to verify it. So I got H union, H1 union, H2. Now look at this one. Why it is not a subgroup? It is not a subgroup because it is not satisfying closure property. Let me check closure property, friends. See closure property. I took 2 belongs to H1 union H2. I took 3 belongs to H1 union H2. But if I calculate 2 plus 3, which is equal to 5, that 5 is not available in H1 union H2. Can you find 5 here? No, we cannot find 5. Therefore closure property does not satisfy. Hence it is not a subgroup of G. So only first statement is true for this question. Okay, I hope you like this question. Yes, correct, Kundan Kumar. H1 union H2, in this case it is not quasi group also, because closure property is not satisfied. I hope you like the way explanation which I did this question. Most of the students, they think that the union of two subgroups need not be subgroup, that's why it is not a subgroup. No, it is not the correct way to think. Sometimes it may be subgroup also, right? Okay. For example, in the GATE maybe they may ask question like this. Same question they may change the pattern like this, friends. Same question they may ask like this. H1 is equals to 2Z comma plus and H2 is equals to 4Z comma plus. Now is H1 union H2 a subgroup of G? Maybe in the 2023 examination they may ask this question. Now tell me in the comment box, is it subgroup or not? 100% it is subgroup, friends. Okay, 100% subgroup. Therefore I will give one important statement here. Please observe. This statement is also important for you. If H1 comma H2 are two subgroups of the group G, if H1 comma H2 are two subgroups of the group G, then first statement H1 union H2 need not be subgroup. Need not be subgroup of the group G. So the moment if you say need not be, means there are some cases where it may be subgroup, right? So which case it is subgroup? H1 union H2 is subgroup if either H1 is subset of H2 or H2 is subset of H1. Means if the one set completely available in the other set, then definitely their union will become a subgroup. Now look at here, it is 2z comma plus, it is 4z comma plus, right friends? All elements which are there in the 4z also available in the 2z comma plus. Therefore H1 into H2 subgroup of G, 100% correct, it is S. It is subgroup of G. Okay, please write these points also friends, okay. I hope you like this question, right friends? Right, let me move to the next question. Right, please check this question friends. Which of the following statements is or true if G is a finite group of order 67? G is a finite group of order 67. First statement, every subgroup of G is abelian. Every subgroup of G is abelian. Second statement, G is cyclic group having 67 generators. Third statement, there exists an element A belongs to G such that order of A equal to 5. Fourth statement, G has only improper subgroups. See how many concepts we covered in this question. We covered subgroup, we covered cyclic group, we covered order of the element, we also covered proper improper subgroup concepts. Okay. Yes, Suraj. Shiva Agrawal, right? Yes, most of you are giving correct answer. Let me quickly explain the concept inside this question, friends. Okay. Very simple. Here order of G they provided is 67. Right friends, where 67 is prime number. every group of prime order always abelian. Okay, every group of prime order always abelian. Therefore, G is abelian. G is abelian. Once G is abelian, every subgroup of abelian group is also abelian. Okay, every subgroup of abelian is also abelian. Every subgroup of abelian is also abelian. Every subgroup of abelian group is abelian. Hence, first statement is correct. Every subgroup of G is abelian. And if it is prime order, it is also cyclic, friends. Okay, so G is also cyclic. G is also cyclic. But how many generators are there? Number of generators in cyclic group, if the group order is prime, it must be equal to prime number minus 1. Here prime number is 67, 67 minus 1, that is 66 generators. Therefore, it is not correct. They provided 67 generators, but actually we have 66 generators. Okay, G is cyclic group having 66 generators is correct, not 67 generators. Next, there exists an element A belongs to G such that order of A is equals to 5. The basic concept is here, order of any element must divides order of the given group. Order of the given group, right, friends? Therefore, order of A divides order of G का मतलब that is 67. Order of A must divide 67. So we have to take only factors of 67. Obviously 1 comma 67 only. Therefore, order of A is equal to 5 is not possible. Okay, which is not possible. Okay, G has only improper subgroups. See, if the group is prime order group, then only improper subgroups are possible. Proper subgroups are not possible. What is the meaning of improper subgroups? One is identity element group, another one is the given group itself. These two are called improper subgroups. These two are called improper subgroups. Hence, for this problem, 1 comma 4th statement is true. Okay. Right, friends. Next question. This question also related to group theory. Which of the following statement is or true about the group G of order 4? So they provided order of the group G is equals to 4. First statement, G is always abelian. Second one, there exists G such that every element of G has self inverse. Third one, there exists at least one element A not equal to E in G such that A inverse is equal to A. Every such group G must contain every element has self inverse. Okay. Please comment your answer in the chat box. You have another 30 seconds time for completing this question. Right friends, let me explain. The first basic concept for solving this question is the least non-abelian group is of order 6, means up to group of order 5 always abelian friends. Okay. If order of G less than or equal to 5, then G always abelian, then G is always abelian. Hence here first statement is true, right? There exists G such that, means there exists G of order 4 such that every element of G has self inverse. Okay, there exists such G, means which is having order 4, every element is having self inverse. Yes, we are having one group for that friends. Okay, that is G is equals to 1 3 5 7 under multiplication modulo H. If you create composition table for this problem, like 1 3 5 7, here we are having 1 3 5 7, the multiplication modulo H. Okay, just quickly fill up the table. This one 1 3 5 7, so like 3 5 7, next 3 3s are 9, by dividing 8 we will get remainder is 1, 3 into 5 15 divided by 8 we will get remainder is 7, 3 into 7 21 divided by 8 we will get remainder is 21 divided by 8, you will get remainder is 5. So like that if I continue, you will get here it is remainder is 7, so here remainder is 3, sorry, 5 into 5 25 divided by 8 you will get remainder is 1, 35 you will get remainder is 3, 73 21 you will get remainder is 5, and here 7 into 5 35 you will get remainder is 3, and 49 will get remainder is 1. Right friends, so if you observe this group, every element is having self inverse. How to find inverse for the composition table? Simple, it is identity element, right? It is identity element. Now in the composition table, every row identify the identity element, in every row identify the identity element. So you are getting identity element 1 by performing operation 1 with 1, therefore inverse of 1 is equals to 1, 3 operate with 3 to get identity element, inverse of 3 is equal to 3, similarly inverse of 5 is equal to 5, inverse of 7 is equal to 7. This group is invented by the mathematician Kleene 4 group. This group name is Kleene 4 group. Okay, so this kind of special group definitely they will ask in the GATE paper also. Okay, like in the last year they asked Peterson graph, right, in the same way. Therefore second statement is true friends, second statement is true, right. Next, there exists at least one element A which is not equal to identity element such that A inverse is equal to A. See, if the group is having order 4, the group is having order 4, then if I consider G is equal to suppose E A B C friends, E A B C, you know that identity element always having self inverse, identity element always having self inverse. One possibility is A inverse may be is equals to B, then obviously B inverse is A, then C must have its inverse, C must have inverse. This is one possibility. A inverse is B, B inverse is A, and C is in having self inverse. Other possibilities, every element may have self inverse. Therefore, in either of the cases, there exists at least one element which is having self inverse. In this example, that one element is C. In this example, that element is every element. Okay. Therefore, this statement also true. Next, every such group G must contain every element has self inverse. No, it is not possible to have every element is self inverse. Look at one example which you provided in the class. G is equal to 1 comma minus 1 comma I comma minus I. It is a group of order 4. But every element does not have inverse. Every element does not have self inverse. Right? So, in this problem, 1 inverse is 1, minus 1 inverse is minus 1, but I inverse is minus I inverse is I. So, every element does not have self inverse. Okay. So, therefore, this statement is wrong. I hope you like this analysis, friends, right? Only 1, 2, 3 are correct. Express your feelings in the chat box. Let me see how many of you are feeling interest about these questions. It will give motivation for me to teach further concepts. Right. Next question. Question number 14. It is very simple question. Only to recollect the basic concepts I explained this question, friends. Okay. Very simple question. We don't want to waste our time. Try this question. Ashtosh Roy. Nice. Thank you. Yes, Harsh Jain, you are right. It is straightforward question, friends. We don't want to waste time for this question. It is a recall based question, right? So, the basic idea for this one is, if S is a set with 4 elements, then the total number of edges in the assay diagram of P of S comma subset, where P of S is power set of the set. So, this question we already discussed in the basic formula. If cardinality of S is equals to n, the number of edges in SI diagram must be n into 2 to the power of n minus 1. This is a formula for number of edges in SI diagram. Here they provided 4, therefore 4 into 2 to the power of 4 minus 1, right, which is equal to 32 is the correct answer, friends. 32 is the correct answer. So, this is the explanation for this question. If anybody want, you can copy it. These are recall based questions. You have to remember this formula. Next one. Question number 15. In an experiment, 4 differently colored dice are thrown simultaneously and numbers are added. Find the number of distinct experiments such that total is 18. No, Suraj, it is not correct. Check it, Suraj, once again. सूरज आनंद एक बार चेक करो. Yes, Raman Singh, that is correct. Right, friends. Observe how I am going to solve this question. In an experiment, 4 differently colored dice are thrown simultaneously. Suppose the number appears in the first die, I am taking it as x1. Okay, the number appears in the first die, I am taking it as x1. And the number which appears in the second die, I am taking x2. The number which appears in the third die, I am taking x3. And the fourth die which I am taking as x4. If I add up them, it will give total must be equal to 18. Clear, friends? It must be equal to 18. But what are the limitations for x1 and x2 and x3? Each xi minimum value is 1, maximum value is 6. Because die contains 6 faces, right, friends? Okay, numbering from 1 to 6. So minimum value is 1 and maximum value is 6 for I runs from 1, 2, 3, 4. Clear? The basic idea is we want to find non-negative integer solutions for solving this question. That's all. Okay, where x1 stands for number appear in the first die, x4 stands for number appear in the fourth die. Clear? If I add up them, it must be equal to 18. And the limitation is minimum number equal to 1, max number equal to 6 on the die. Now you want to find number of non-negative integer solutions for solving this question. Right, friends? So you can apply classroom approach which I explained. So whenever you are having values like this, better minimum value of x1 is equals to xi is equal to 1, maximum is equal to 6. So what I will do, I will take like this. Let I am taking x1 is equals to minimum is 1, maximum is 6. Therefore, I am taking x1 is equal to 6 minus y1. 6 minus y1 because maximum is 6. And x2 is equal to I am taking 6 minus y2. And x3 is equals to I am taking 6 minus y3. And x4 which is equal to I am taking 6 minus y4, friends. Then what are the limitations for y1, y2, y3, y4? In order to get maximum 6, I can take y1 value equal to 0. In order to get maximum 6, I can get y1 equal to 0. In order to get minimum, I can take y1 value equal to 5. Right, friends? Therefore, the limitation for each and every variable is 0 less than or equals to yi less than or equal to 5. Means minimum is 0. If you put minimum is 0, you will get maximum for x1 is 6. And maximum of y is 5. If you put y equal to 5, you will get x1 value equal to 1. So with this transformation, this equation becomes x1 is nothing but 6 minus y1. So 6 minus y1 plus x2 is nothing but 6 minus y3, sorry 6 minus y2 plus 6 minus y3 plus 6 minus y4. This total is equals to 18, friends. Okay. By simplifying this one, you will get y1 plus y2 plus y3 plus y4 is equals to. So 24 minus 18 which equal to 6, right friends? Okay, 24 minus 18 that equal to 6. What about y1, y2, y3 values? 0 to 5. Earlier it is not non-negative integer solution, it is positive integer solutions. But we have formula for finding non-negative integer solutions. Please recall non-negative integer solution formula. If we have x1 plus x2 plus up to so on xn is equals to r, number of non-negative integer solutions formula n minus 1 plus r c n minus 1. This is called number of non-negative integer solution formula. I cannot apply this formula straight away by taking x values, because x is not non-negative, it is positive integer solution, because minimum of x1 is positive, that is 1, right? Therefore I cannot straight away apply this formula for x1, x2, x3, x1. Therefore I have taken transformation like this. I got limits for y1, y2, y3, y4 as between 0 to 5. It means that it is called non-negative. Okay, it is called non-negative. So now we can apply this formula, non-negative integer solution formula. So in this example, n means 4, so n means 4, therefore 4 minus 1 plus r means that equals 6, c n minus 1 that is 4 minus 1, right friends? Okay, so that is 10 minus 1 that is 9c3, its value is 9c3. I hope 9c3 value is equal to 84, clear? So 84 ways we can satisfy this equation, 84 ways we can satisfy this equation, clear friends? 84 ways we can satisfy this equation, but 84 is not the correct answer. The reason why 84 is not the correct answer, let me explain. If you see the solution for this one, there is a possibility y1 is 0, y2 is 0, y3 is 0 and y4 may be 6, that equals 6. This solution also included here. Okay, another possibility is 0, 0 plus 6 plus 0, that is also 6 included. Another possibility 0, 6 plus 0 plus 0, that equals 6 also included. Another possibility is 6 plus 0 plus 0 plus 0 equals 6 also included. These 4 solutions also included in 84. Okay, but what are the limitations for y? Maximum limitation is 5 only. If maximum limitation is 5, we cannot take this solution because y value exceeds 5. We cannot take this solution, we cannot take this solution. Therefore these four solutions must be excluded from 84. Okay, therefore number of solutions for this problem 84 minus 4 that equal to 80. The strategy क्या है? The strategy is very simple. We want to find number of non-negative integer solutions, but here x values are positive, that's why we are converting into non-negative integer solutions. We found number of non-negative integer solutions, but after finding, verify are all the solutions are involved in the problem or not? No, because maximum limit for y is 5. There is a possibility I can take y1 is 0, y2 is 0, y3 is 0, y4 is 6. This is also satisfying given equation. Therefore I had subtracted all possible cases. By subtracting them I will get answer is 80. So correct answer for this question is 80, friends. I hope you like this question. Yes, Kundan Kumar, you are right. Raman Singh. It is correct only. Is it clear everybody friends? Okay. Let me move to the last question. Yeah, this is a solution which I provided here. Okay. And if you want, you can copy it. In the last line we had to subtract 84 minus 4, that equal to 80 is the correct answer. So this question solution already provided in the class notes. Okay, you can expect questions like this friends, so I don't want to explain once again this question. So kindly follow this question and practice this type of models. Okay, everybody please copy this question and you can try by yourself, because this type of problems already explained in the class. Okay, I'm expecting one question from this model in this year. So for solving this question strategy very simple friends. Okay, now look at this. For all x p of x implies q of x implies for all x p of x implies for all x q of x. So if you observe this one, left side and right side we are having same quantifier, that is universal quantifier, right? Just assume we are eliminating that universal quantifier. Okay, assume that we are eliminating that universal quantifier. If you eliminate that universal quantifier, we will have here it is p of x implies q of x implies it is p of x implies q of x, like this, right friends? Now recall CP rule, which is conditional proof rule. The conditional proof rule says that whenever RHS value is having implication symbol like this, implication symbol, we can bring first premise to the left side with the help of conjunction operator. So by using conjunction operator, we can write it as P of x implies Q of x and P of x. This total implies Q of x. So this rule is called conditional proof rule, which is CP rule. Clear friends? Conditional proof rule. Now P of x implies Q of x, and P of x means which is giving modus ponens. Modus ponens. So this total result must be equal to Q of x by using modus ponens. Hence the result is Q of x. Okay. This simple strategy for solving this question. Here we can apply modus ponens. So we are getting Q of x. So once it is true for this x value, now both sides we can apply same universal quantifier. We will get the same result also. This is one way to solve this question. Clear? In the similar manner you can solve remaining questions also. These question solutions already provided in the class notes. Please go through them friends. Okay. The last question for today's session, which is most interesting. So try to solve this question. Harish Jain, that case will be allowed. Harish Jain, 0051 case will be allowed. That's why I am not subtracting that case. We have two inferences. We want to verify which of the following are valid inferences. So this problem can be done in so many ways friends. So but we are going to solve this question with a shortcut method approach. Okay. So let me explain what is the basic strategy for solving this question. Okay. Observe how quickly we are going to answer this question friends. See this statement whatever they provided here, first inference R implies S, P implies Q, R or P implies S or Q. So this statement we can write in three different ways. Okay, left side we can call premise, right side we can call conclusion. This statement we can represent three different ways. The first approach is looking like this. See, first premise followed by second premise followed by third premise, hence conclusion is SRQ. This is one way of representing same statement. The second way of representing is we can separate each and every premise with the comma operator, and right side conclusion is SRQ. And the third way of representing this one is comma operator stands for conjunction, so we can use conjunction symbol, and the conclusion is here SRQ. Conclusion is SRQ. Then how we are going to solve this problem? So generally people, they are going to solve by using truth table, which is taking a lot of time. Here we are going to apply shortcut method. Please observe, friends. The shortcut method for solving this question, just focus R implies S and R. Are you able to see modus ponens in this problem? Modus ponens rule is A implies B and A gives result is A implies B and A gives result is B. That is called modus ponens. Here R implies S and R, this gives result is yes by using modus ponens. Similarly, P implies Q and P. Again we can apply modus ponens, and here it gives result is Q. बीच में क्या symbolize है अंदर R, therefore we can use R symbol. That's it. That is simple process. Okay, yes or Q is the correct answer. Therefore inference 1 is true. This is the best approach for solving this question, friends. Okay, so I applied modus ponens result. Let me check next question. This is the next question which they provided, and their expecting conclusion is Q implies P. See how simple we are going to solve this problem without putting more efforts. अब ध्यान से सुनो, first verify are able to solve this question by using modus ponens and modus tollens. Okay, let me recap modus ponens and modus tollens. A implies B and A will give conclusion is B. That is called modus ponens. Okay, and A implies B, negation B will give conclusion is negation A. This is called modus tollens. We will apply these two properties for solving this question. Okay, now look at here, friends. Negation R W, we can also write this statement as R implies W. You know the basic principle, right? The basic principle, P implies Q can be written as negation P or Q. This is a basic principle. So by using basic principle, we can write R implies W is nothing but negation R W. Now it is R implies W and it is negation W. By using modus tollens, apply modus tollens here, you will get result is negation R. Result is negation R. Right, friends? Okay. Now it is negation R implies S implies Q, and here it is negation R. Now apply modus ponens. A implies B, A will give conclusion is B. A implies B, A will give conclusion is B. Here it is called A, it is called B, and here it is A, friends. Therefore, we will give conclusion is S implies negation Q. We will give conclusion is S implies negation Q. Simple funda, it is A implies B and A will give conclusion is B. So after getting S implies negation Q, we are having another statement is negation P implies S. Now apply transitive property. Transitive property says that, recall transitive property, A implies B and B implies C will give conclusion is A implies C. That is called transitive property. Right, friends? Okay. So since we are getting here S implies negation Q, and what is the statement here? Negation P implies S. Please observe, friends. I am using different color, you will get more clarity. This is negation P implies S. It is S implies negation Q. So by using these two, what we can conclude that it is satisfying transitive property. Therefore, by using these two we can give conclusion is negation P implies negation Q. So by using these two we can write like this, but it is equivalent to its contrapositive. Who is a contrapositive of negation P implies negation Q? That implies Q implies P. Okay, it is equivalent to its contrapositive, that is Q implies P. Hence this statement is valid. See how simple we solve this question if you know the properties very well and if you know how to apply those properties. Most of the students, they are doing a lot of hard work by taking truth table. Don't apply truth table approach. This is a basic strategy we had to apply for solving the questions. Okay, I hope you like this approach. Okay, watch this video 2-3 times, you can understand what approach I applied here. Okay, so that's enough for discrete mathematics get through questions concept, friends. I hope you enjoyed today's class. If you really enjoyed, just express your feelings in the chat box. Okay, I wish you all the best and happy Republican Day for today. So wish you good luck. God bless you all. Okay, thank you very much. Okay. ఒక నిమిషం నేను డౌట్స్ చెప్తాను. గుడ్. Thank you everyone. Thank you so much.